Okay, in this video I'm going to show you how to do regression with the data analysis Toolpak. And so what you can do here is go to data, place for it on the PC, and find your data analysis Toolpak here, and go to regression, press OK. Then you want to choose your input Y range, and this is going to be your outcome variable. So make sure this is your outcome variable for Y, and your input X range should be your predictor variable. So for this example we have test 1 and test 2. Now I want to predict test 2 scores with test 1 scores. So our predictor variable is the test 1, and our outcome variable is test 2 scores. So for our Y input range, we're going to select test 2. I'm going to highlight all of that data. And then for X, it's going to be test 1. I'm going to highlight all that data. Okay. And then I'm going to select the output range, but you don't have to. You can put in a new worksheet if you want to. And I'm going to get the residuals. You don't have to. And then I'm going to press OK. And let's see here. So we have quite a few tables here, and I'll go through them. So this first one has some R's. So this first one is actually the correlation between X and Y. Now it says multiple R because if we had more than one predictor variable, more than one X variable, then this would account for that. But in this case, since we only had one predictor variable, this is just the Pearson's correlation. Then this is R squared, so this is just the square of the multiple R. And I haven't taught you about this yet, but this tells you what percentage of variance is accounted for by the X variable. So what percentage in your Y variable is accounted for by your X variable. The adjusted R squared takes into account how many predictor variables you have, so it kind of has a penalty for each predictor variable that you have, and it shouldn't be negative, but it ended up being negative because the R square is so little already that it became negative. So this isn't really helpful. It's just saying like we're not really accounting for much variance. And then we have the standard error, and then how many observations we have. So we only had 5 observations. And that's talking about the number of students, so the pairs of observations to be more accurate. And then we have an ANOVA table, and so this isn't helpful in simple linear regression. In simple linear regression is when you only have one X variable, one predictor variable. This is helpful when we have multiple predictor variables. So if we wanted to predict test 2 scores with, say, maybe the time you studied and your test 1 score, then this would be helpful. So the F is kind of an overall test, just like in ANOVA. So you had an overall test to see if there's any differences, and then you would want to do follow-up t-tests to see if there are differences. And that's kind of similar here. So you would see if the overall F is significant, and in this case it's not. And then you would want to, if it was significant, then you would want to go down here and interpret all the slopes that there are. But in this case there's only one, so we kind of ignore this for now. But you can see that the p-value for the F here is the same as the p-value for the slope here. And that's because we only have one predictor variable. So this is a test to see if any of the slopes are significant, And then if it is significant up here, it's saying that well, at least one of them is significant, then you would go down here and see which slopes are significant. And so you want to do that because we're doing multiple t-tests. But again, this is only helpful if we have multiple predictor variables. And then down here we have the intercept, so it's estimating it at 82.665, and then it has a standard error for the intercept, its t-statistic, and its p-value. Remember, this is a p-value for a two-tailed test, and it happens to be significantly different from 0. So again, remember that we're testing to see if the intercept and the slope are significantly different from 0. So in this case it was. And then it has a confidence interval for the intercept here. So it has the lower and the upper limits. And then here we have the slope. So this is our predictor variable. So this would be the slope for test 1. We had multiple predictors. They would be down here. And it's estimating the slope to be 0.044. And here's its standard error for the slope. And its t-statistic, and it's not very high, so our p-value is pretty big. And so this slope for test 1 is not significant because the p-value is so high. And we also have confidence intervals for the slope. And then I picked to get the residual output. You don't have to, but here is the predicted values for each student and the residuals. So it just goes ahead and does that for you. Right, and that's it. Well, also you can make a scatter plot. So let's see if we can do that. So I'm going to highlight test 1 and test 2. And I'm going to make a scatter plot here. Alright. And then you can add axis titles. So this would be, I think this is going to be test 2. And this would be test 1. And then I also want to add a trend line. And then, so this is the line of best fit that we're trying to estimate here. And then I also want to put the actual line. So display equation on chart. Move that up here. And you can see it has the intercept and the slope that we got from this other output here. And it puts it in a nice little equation for you. So that's just kind of a review from way back in our bivariate phase, but also showing you that we can put this equation now. Alright, now that ends this video.